I'll give a quick thumbnail of what Celtic Sea Power are about in a moment for those not aware, but we're delighted to have Jack from the Catapult and Becky from the Regen. I say supporting, but what I mean is making this run, because I have very little knowledge of anchors and mooring, has to be said. And then over to we'll go through the technical challenges and commercial barriers, and also Becky will pick up on innovation and plans that Regen have for this initiative, and also we'll bring it back to what does good look like in terms of how do we overcome this capacity problem and really take on this challenge in a way that derives benefit to the Cornwall specifically, but the UK and the region more widely. So, and just a note there, if it's not obvious, the webinar will be recorded and we'll make it available afterwards. So if you do interject, just please be aware of that, because you will be recorded for more. So a quick note on Celtic Sea Power. We're quite an unusual entity in that we're wholly owned by Cornwall Council, and we're charged with maximising economic benefit from Celtic Sea Flow, and also streamlining its development. So there are two guiding aims, and we address that sort of head on with long lead items of zonal planning consenting, which is my colleague Neil, infrastructure, ports and grid, headed by Tim James in the Welsh office, stable regional industry, which is my area. Part of this webinar is part of that, and workforce development, which I oversee, but I have to give complete credit to Olaf, who's taken that on as his own as well. So we're a small entity, but 17, maybe 18 now, I'm not sure, based in Hale and Pembrokeshire. So that's who we are. Many of you will know that, I realise. So this project itself, also known as the project, but strategic sector development, it's essentially a partnership between Celtic Sea Power and Offshore Renewable Energy Catapult, and it builds on the last couple of years of work under the Cornwall Flow Accelerator, which is an ERDF funded project. Again, many of you are familiar with it, and it builds on that, and it will underpin the work of the Cornwall Flow Commission, which has just come out in the autumn statement. So that's work in progress. We're figuring that out as it comes, but it will become apparent in due course. Really, the activities here, what we're trying to do is to really drive delivery of Celtic Sea, and crucially for benefits for the region and also the UK. So that's what it's about, and it's funded by Levelling Up as well, so the Shared Prosperity funding. So the objectives here for this particular part of the project and this webinar are really about catalysing private sector capacity. So by private sector we mean, for the most part, you guys, small companies and big. We're very aware that small companies have got high ambitions to grow, but also bigger companies who might not have been in offshore wind before may pivot in. So part of that is forming consortia, forming consortia and partnerships. For us, it's about looking for the best tactical, strategic use of inward investment and de-risking interventions, and really allowing the UK capacity to deliver offshore wind to grow. We have the capability, but have we got the balance sheet to really drive it forward? It's the third webinar of a series of what we hope will be 5. We've done concrete, we've done cables, inter-array cables. They will be available as recordings and slides very, very shortly. And now we're on anchors moorings, got operations maintenance coming on next Monday, so it's pretty quick. Look on LinkedIn and we'll send it to you afterwards. And then we hope to follow up with cross-cutting products and services, which is capture the other, which are quite significant others, like marine operations and vessels. We'll hopefully squeeze that in before Christmas. That's our intention. The pipeline itself for Celtic Sea floating offshore wind looks like this. It's constantly changing. There's maps change every little while, as you know, if you're keen Crown State watchers, being refined all the time. And the tests and demos, which tend to get most the attention, understandably, because of development that not quite space on the ground, but not far away. The Twin Hub, which is approaching a milestone soon, which is the old Wave Hub site. We'll put 32 megawatts in, getting what we think 26, 27. They've got AR4 CFD. Erebus was the one that we had expected to see in AR5, but hopefully it will follow with AR6. We've got Whitecross up in Braunton, and Sieco Flaventis, and also Simply Blues Valorous as well. So we're hopeful. Well, we're pretty confident, I think, of a gigawatt by about 2031. It's happening pretty quick. That's a significant amount of power. Hinkley is about 3.5 gigawatts, 3.3, I think, and that number there. But it's these big numbers towards the end. 4.5 gigawatts by 2035, and ambition for 24 gigawatts by 2045, which has also been added to by the Crown Estate recently. I think they intimated another 12, can't quite remember, but certainly there's plenty of wind out there. So that 4.5 gigawatt is a solid target for 2035. is significant. We're in the region of, again, it changes, but I think depending on the technology, 260, 270 turbines on a platform, the base for a football pitch, and turbines high as I think the shard always gets thrown around. I think it's a bit shorter than that, but we shall see. It's serious industrialization here. Make yourself a hub, Mark, make a cup of tea. So there we are. There's a good impression of the scale of these things. And just to say, we're not doing it alone. There is a whole region engaged in this. It will be a significant effort across ports, across the infrastructure, across the South Wales, Southwest, and Cornwall. Celtic Sea Cluster has been active for a few 3 or 4 years now. On one level, it corrals a lot of the public sector entities. So Welsh Government very much on board, Marine Energy Wales, the Cornwall LEP, and the Catapult and ourselves are driving it as well. That's likely to be expanded in the near future. But also in terms of practically, it's a great source of it's a great resource. So if you click through there's loads of resources there for free, lots from the Catapult, lots from the CFA, University of Plymouth, University of Exeter, and do sign up as well. I can see Julie online as well, so she's the point person for this as well. So this was a good resource and a good touching point for business interested in flow in the Celtic Sea. Now, here we go. The challenges to deliver that 4.5 gigawatts are many and varied, and sort of somewhat daunting. I won't go into detail on this because the point of this slide is really to say, well, if you look through this, and especially when we look at anchors and moorings, there's risk, there's uncertainty about who will do it and from where it will be based. But what also comes through is the capability in the UK throughout these areas is high. There's no doubt about this high, and I think we can say especially so in anchors and mooring. So the challenge is, which is it's sort of to-do list for the industry, that what needs to happen for the industry. But it's sort of just because what does the region want to deliver? What do we want to do? Well, first of all, what do we have to do? Because the ports will be expanded, roads will be dug up, cables will go in. There's now a regional bound element, this geographically bound element to what we have to take on. But if we can be less reactive, be more proactive, what do we want to take on? Where do we want the investment to go? Where do we want to scale up? Anchors and mooring is very high on the list, and we've seen that in the supply chain capability analysis report by OWIC recently, amongst others, concrete, and basically the theme of these webinars. So you'll see what do we really want to take on. And so you try and flip those challenges into opportunities, and that's the trick we're trying to pull here. Is the ports, the grid, there's necessity, but really, if we've got the capability, where can we build from strength? And if we build from strength, Celtic Sea Flow is obviously right on our doorstep. It's the one that we want to make work, but there is huge export potential for flow off France, off the States, off South Korea. So if we can really build expertise in 1, 2, or ideally 3 or 4 of these areas that will be needed to deliver it, it really will help boost GVA and jobs in the UK. So the phrase that it keeps coming, I really like it. I think it's coined by Tim Stiven of the Crown Estate, is no regret activity. If there's an investment decision pending, flows a nice bit of confidence, which perhaps you might say in this region we've sort of lacked for a long time. It might just push the edge over. So okay, let's invest in it. Let's kind of think positively about what we can get into flow, but it's by no means uncertain. By no means certain. And that the lessons from the precedent from offshore wind are quite what's the word? They raise questions, should we say, about whether we can deliver it, whether we have the capability or not, should we say? And the capability there, and the programs here, Fit for Offshore Renewables, I think is very much one of the OWGP. Really good programs for developing smaller companies into offshore wind. That's great. Building capability. But actually, where we've you could argue we've fallen short in offshore wind has been capacity. Just other companies with the balance sheet, the appetite for risk, take those problems away and figure out the technical solutions once they've got the contract. That's been a big shortfall, I think it's fair to say, in Fix previously. So that's the key dilemma, and this is all about capacity building. This is what we're interested in, is how to build capacity. So here's the kind of the go-to slide for me now, is that this is a utopian dream. 4.5 gigawatts of flow in the Celtic Sea by 2035 and delivered with high UK content. These are the key areas we've picked out and exploring the subject today, and how we're going to do that. We've got all this capability, big and small, sitting over here, but what tends to be discussed at the conference I go to it does become a bit circular. It feels like there's lots of reports get generated. We have the Catapult brilliantly articulating the challenge, but we kind of need 1 or 2 entities to just take that challenge away, take it on, So what we're really doing with these webinars is reaching out to you, big or small companies, to ask the people who hold the capability, how are we going to do this? How are we going to get this done? So we aim to, our role we see as being to ease that path. In the process of doing this, we really want you to talk to each other. We have an online forum called Piranha coming soon. Yes, we're calling it Piranha. We left Matt alone with the designer for 5 minutes, and that's what happened. So that will be an online forum for you to get heads together and figure out, okay, how can companies complement each other and take on these really big, serious challenges. This webinar is the first part of that. Piranha is the next, and we're also looking at asking you to form consortia to present how you would deliver this, how you would take these challenges away at scale in sometime in the new year. What we're looking for is obviously, as Jack will articulate, the technical challenges, commercial barriers. We can articulate it, but we're very, very aware that what we think is secondary to what you will have to do. What what the commercial sector will have to overcome. So those will have to be identified and really articulated, and really with solutions in mind for the investment or interventions. We've seen some really good noises coming out, if you follow the news recently, in terms of sustainable industry reward schemes in future CFD rounds, and how from Department of Business Trade, all those, the tide is turning a bit, and how we can really make this happen at scale. Hopefully with that we'll kickstart delivery. And the underlying theme is positive impact on Cornwall, because we are owned by the council, fairly naked in that, and the UK. That's the driver. So that's the vision. Hopefully you'll be a part of that journey. So with that, I'm reasonably on time, I think. I'm going to pass you on to Jack to talk about technical challenges and commercial barriers.
Okay, thank you, Phil, and good afternoon, everybody. It's a pleasure to present to you today on the technical challenges and commercial barriers for mooring and anchoring systems in floating wind. And I'm Jack Patterson. I'm a team leader in the floating offshore wind team at the Offshore Renewable Energy Catapult, and I've been actively working in this space for the best part of 2 years now. Next slide, please, Phil. In today's session, I'll briefly summarise who we are at the Offshore Renewable Energy Catapult and our flagship GIP, the Floating Offshore Wind Centre of Excellence. I'll summarise various mooring and anchoring options and what this means in terms of supply chain requirements and capacity. And a quick delve into some of the challenges from an operational perspective, covering installation O&M and the outlook for vessels in conjunction with those topics. And we'll hopefully have a bit of time for a brief summary, and certainly I think we're going to have a Q&A at the end of today's session. I should say there's a lot of content on my slides, so apologies if I don't touch on everything in detail, but I anticipate that the information will provide a useful reference as I progress. Next slide, please, Phil. So just briefly on the Offshore Renewable Energy Catapult, we're the UK's leading technology, innovation and research centre for offshore renewable energy. And our mission is to accelerate the creation and growth of UK companies in the offshore renewable energy sector. We've got a number of unique facilities and research and engineering capabilities, and indeed we're expanding these capabilities as we speak, especially in the mooring and anchoring space in our new Aberdeen Floating Offshore Wind Innovation Centre. If you want to know more information on that, I happily take some queries after today's webinar. We bring together innovators, industry and academia, and accelerate the creation and growth of UK companies, whilst also reducing the risk and cost in renewable technologies and growing the UK's economy and enabling that transition to a low carbon economy. Next slide, please. So I mentioned our flagship GIP, known as the Floating Offshore Wind Centre of Excellence, and this is all about accelerating the commercialisation of floating offshore wind. And it's a collaborative industry programme where we support different stakeholders in the form of developers, academics and supply chain partnerships. And indeed, we work with 19 project developers as we speak today. And we broadly work across a number of different work streams, which are listed here in the form of technology development, supply chain infrastructure and construction, and operations, development and consent, and really focusing in on that delivery of net zero. And of course, we also collaborate with other industry programs, initiatives and activities to augment and accelerate our activities within the Catapult and the Centre of Excellence. Next slide, please. So within the Centre of Excellence, we have this strategic programme known as the Mooring and Anchoring Systems Strategic Programme. And why are we focusing on this? Well, mainly mooring systems and installation account for about 5 to 10% of total capex of a floating offshore wind project. And we are focused on this to improve the floating offshore wind industry's access to suitable, reliable and cost-effective mooring and anchoring technologies. Of course, mooring and anchoring systems are critical in floating offshore wind projects, and there's a range of existing transferable technology, but a step change in terms of supply chain capacity in terms of the scale. There's a new loading regime presented from floating offshore wind, particularly in shallow water, and when you couple that with the dynamic cable system, there's a need to reduce the costs. And the UK supply chain has good experience in designing and supplying and installing mooring and anchoring components, but there is an opportunity to ensure capable, competent and cost-effective mooring supply chain develops in time to address the needs of the floating offshore wind sector. A short reference to the right-hand side, which summarises mooring and anchoring taxonomy nicely, starting initially with the anchor, the ground chain or wires, clump weights to support the grounding and station keeping of the mooring system, and buoyancy support, which can be needed in some occasions to limit the seabed interaction, particularly for synthetic ropes. And then you have the upper mooring section connected to the platform, usually in the form of a chain for tensioning requirements, although there are some variations to this topside connection that I'll mention slightly later on. I also include a number of key design drivers that must be considered when designing moorings for floating offshore wind. Of course, maximum excursion limits are key, maintaining the integrity of the cable and the station keeping of the platform at large. And the footprint and spacing has to be considered. This is generally within the range of about 7 to 10 rotor diameters, although these can be more densely packed if the mooring configuration allows and you can account for suitable weight recovery across your array. The avoidance of snatch loads is critical, and you need to ensure that the mooring geometry and design tension is sufficient for operations. And there may also be a case and a requirement to standardize mooring and anchoring components. And in the next few slides, I'll go into a few of these technologies in more detail. Next slide, please. So very briefly, it's worth mentioning a range of different mooring configurations that can be considered for floating offshore wind. On the first row, we have catenary systems, which define no uplift at the anchor location, and a system stiffness which is primarily driven due to system weight provided by the chain and the shape of the catenary system. So the geometry really provides that reactive force. The plain chain can be used in these catenary options, although you can introduce other technologies or materials in the form of synthetic stretchers in the form of the riser section. In some cases, you can also have a ballasted catenary, as we see on the right-hand side, which provides enhancement to the station keeping capability of the mooring, especially in shallow waters, which can avoid excessive chain diameters. In the middle row, we have semi-taut systems, and they're a hybrid of two systems in the form of taut and catenary. And these are a mixed line makeup of chain plus synthetic rope. Mooring system stiffness is dependent on the line elasticity and also the grounded mass that's provided by the chain. And in the case of the buoyant semi-taut, which you see to the right-hand side, this may include clump weights in the ground chain and a buoy to avoid touchdown of the synthetic rope in the seabed, which can be detrimental to the integrity of the synthetic rope over time. And in the last row, we have taut systems. Firstly, taut systems for those like semi-submersibles or similar. That does define a vertical load on the anchor, although the mooring line is usually at a relatively shallow angle, as we see on the left-hand side. Although mooring system stiffness depends heavily on the line elasticity and can be tunable via mixed line type makeups and in the form of other jewellery systems, again, which I'll go into a bit more detail later. And finally, we have the tension leg platform that's gaining a little bit of traction in the offshore or the floating offshore wind industry at the moment. And that's a full vertical load on the anchor point. And the vertical tension in the tensions can be supported by tubular steel or synthetic ropes. And the mooring system's stiffness depends heavily on line elasticity and also the opposing buoyancy uplift from the substructure. As I mentioned already, there's an inherent lack of standardization in moorings for floating offshore wind with so much variation in substructure types and site conditions. And is it achievable for us to agree on suitable ranges for floating offshore wind mooring components in time? That would potentially come at the cost of lower optimization on a site-by-site basis, and to a certain degree, that capability or that may be answered by the availability in the supply chain, which I'll move on to next. Next slide, please. Thanks. So in terms of mooring lines, first of all, chain is often considered as the main mooring line solution, but has high susceptibility to global steel prices and overall availability. Chain has a number of variants, which some would refer to as excessive in terms of bar diameter, with examples reaching up to 220 mil. And that is stretching the limits of anchor handlers and impacting installation efficiencies, which I'll go into a bit more detail later. Alternatively, there are several synthetic ropes in the market, which have been used for floating offshore wind demonstrator projects. And the most common synthetic rope at present is polyester, or potentially HMPE. But the use of nylon and bioplastics are also gaining traction, and they're being explored, although they're currently at a lower TRL at the moment. And we at the Catapult, as a number of other research institutes, researching the capabilities of nylon at scale. In the UK, we have no mooring chain production, and chains will likely be play a part in many projects, even for grounded lengths, upper connections, or simply by necessity for tensioning requirements. And there will likely be a need for increased synthetic rope manufacturing and improved availability of key ancillaries such as sockets and splicing solutions. And the installation of synthetics will also demand significant volumes of transportation reels that will need to be standardized and potentially improved in terms of logistics, as these often demand a lot of space, whether it be on the vessel or indeed the quayside. Next slide, please. So the next item is jewellery, which is quite a broad term that can capture many components, but are vital in mooring configuration makeups. Buoyancy modules used in semi-top variants are not thought to be of significant bottleneck in terms of supply. However, if there is a significant uptake in these solutions, combined with clump weights, increased capacity will be needed within the UK and across Europe. Load reduction devices are fairly new to the market, and these offer peak load shaving and have the potential to reduce the diameter of key mooring elements. But there's a key need for development within the supply chain, proving the reliability of these components and service, and also present the opportunity to integrate condition monitoring systems, which again, I'll get into slightly later. Of course, mooring configurations depend hugely on connecting components such as shackles and links, and these are typically forged, and we have a reasonable UK supply chain, although new fabrication methods could be exploited through greener manufacturing processes, which also will apply to chain. And the question is, will we see an increase in combined chain and connector manufacturing facilities in the not too distant future in the UK? And will this also depend still on the importing of steel from elsewhere across the globe? Next slide, please. So tensioners and the next item of jewellery, which are required through installation and may be needed throughout a platform's lifetime to ensure the required pre-tension, or in some cases, installed tension can be achieved in hookup operations. These can be located on platform connections or as inline solutions, and whilst there's no bottleneck foreseen at the moment, there could be a need for increased availability and time depending on the design decisions made by developers. Topside connections can come in a variety of different forms, provided they may provide a means to connect and disconnect to the platform, and there may be a need to upscale in manufacturing capacity to meet UK demand. I state here, based on previous studies, that there could be a need for connections to withstand up to about 2,000 tons minimum brake load, but that could actually be higher in practice, again, depending on the sheer scale of some of the floating substructures and turbines that are eventually deployed in time. And there will also be a demand for quick connectors depending on the O&M strategy that's employed by developers. As it stands at the moment, we only have the tow-to-port solution to do any major component exchange. So there's a lot of emphasis on these newer solutions that are coming to the market. So quick connect systems come in a variety of different forms, and they're under development, as I mentioned. And they're intended to ease the means of hookup and disconnection to accommodate for that installation and also tow-to-port strategy. They really come into their own in that strategy, and as it reduces manual intervention and can facilitate uninterrupted production when solutions incorporate the dynamic cable connection to boot. And some mooring only connectors actually have class type approval already, although there will be a need for technology qualification and demonstration activities completed by entities like ourselves and class societies. And we are facilitating alongside our partners within the Centre of Excellence to support the qualification activity and support generally the funding of that class type approval. So the next slide, please, Phil. So in terms of anchors, these can range from a variety of different types, starting primarily with drag embedment anchors, which lend themselves to catenary systems mainly. And proof loading can be an issue with these anchors, especially where there's loads of greater than 400 tons are needed, which requires tensioners and multiple vessels to achieve that. Piles can be in the form of driven, grouted and suction, and can tackle tough bedrock and can cope with vertical loads. But the fabrication depends on rolling capabilities, and there's not an awful lot at scale for rolling capabilities within the UK. Indeed, there are some specific plate anchors to accommodate vertical loads that have been designed, such as the Sepla, while torpedo and gravity anchors could also have a place where conditions allow. In terms of the Celtic Sea, a study that we completed in the Catapult, which was mainly focused on the upper sediment layer, indicated that DAAs, or drag embedment anchors, suction, drilled and grouted piles may be the most prominent options. And it's likely that developers will need to order early to secure sufficient anchor capacity to meet the demands of their project. However, there is a case for novel and lower profile designs such as Reflex Marine's Javelin or Schottle's Swift Anchor to introduce efficiencies in terms of supply and also the installation activity. Next slide, please. So I won't dwell on this slide extensively, but it's important to flag that a lot of the work that I presented on the previous 5 slides or so is captured in the Floating Offshore Wind Centre of Excellence public report entitled Mooring and Anchoring Systems Market Projections, and that's available on our website. And this sought to quantify the demand of mooring and anchoring components through to 2050 as exemplified on the left-hand side. And this drew attention to the fact, and hopefully it's coming across, that we do need to scale up in all areas, and there's a lack of chain globally, particularly for those larger diameters. And there's a requirement and a commitment for investment and support from the government to meet that investment endeavour, and there's strong opportunities for UK content to emerge in time. And indeed, as I alluded to earlier, there are potential testing bottlenecks. We really need to be able to demonstrate the capability of these technologies in service. And a lot of the work we're doing in the Catapult, both with new rigs that we're installing at our floating facility in Aberdeen and through our technology qualification programme, we'll hope to address some of those bottlenecks and get more components and suppliers into the marketplace. Next slide, please. So if you just scroll through those, please, Phil, that'd be great. Moving on to the operational aspects of mooring and anchors. Firstly, with installation, this can be represented in 3 predominant steps. So we start with the installation of your anchors, the installation and connection of the mooring chain to the anchor, and possibly this chain or mooring line can be wet stored ahead of substructure installation. And then finally, hookup of the lines to the substructure itself. What's evident here, there's a lot of dependency on suitable and capable anchor handling vessels. And on this next slide, I'd like to draw attention to some of the challenges faced for vessels looking forward to commercial scale projects. So I've pinched a few powerful examples from Pareto Shipbrokers, who have assembled and presented recently at the RUK's Floating Offshore Wind conference in Aberdeen. And firstly, when considering chain and taking the example of Hywind Tampen, each platform has 3 mooring lines, and those are about 730 meters in length per line, and that's about 2,200 meters of chain per substructure. If compared to one of the vessels that was used for the installation of that project, the Scandi Iceman, this vessel can carry around about 4,500 meters of chain per trip and a 75% stowage, meaning it could only carry enough for 2 substructures per trip. This probably wasn't too much of an issue for the project the size of Tampen, but at commercial scale, transits to and from the port and reloading could lead to significant time during the installation. And this could also be exacerbated by increasing chain sizes, as we see on the images on the right. And if we go back to that earlier example of 220 mil chain, this would limit the Scandi Iceman to only one mooring spread per trip. And again, that's going to have a massive impact in terms of your installation effort and the overall cost to deploy your project. A move to synthetic rope doesn't necessarily make things much easier. A suitable vessel such as the Scandi Vega is only capable to carry about 2 to 3 mooring spreads per trip for a 3 kilometer full-scale rope per substructure. And similarly, anchors demand significant deck space, and a standard 40 by 20 meter deck will be constrained in the number of anchors it can handle per trip, as exemplified by the estimates we see in the bottom right. And the logistical advantages or disadvantages of each anchor may sway anchor selection decisions by developers. And in reality, a holistic assessment of payload, installation rates, met ocean limitations, and similar will be vital to fully appreciate vessel demand for each specific project. Next slide, please. So to frame the challenge for operations and maintenance, starting with risk and reliability perspectives, there is little known about the probability and prevalence of mooring line failures in the floating offshore wind industry today. And this is a key concern across the industry. What we do know is a lot about the failure mechanisms and failure modes. And I've cherry-picked a few examples in the list below. But these have been largely assembled from the experience in the oil and gas sector. And despite many years of analysis and a strong appreciation of the failure mechanisms and modes, oil and gas still continues to experience unexpected and unforeseen failures. And this exemplifies why there's great concern within the floating wind industry, as the sheer number of installations, loading constraints and cyclic tensioning of mooring lines could lead to significant number of failures if we don't address the problem head on and better understand some of the dynamics and also how to better accommodate for those failures. The consequences of these failures could range from a number of different examples as I've listed here. So we could have cascading impacts due to the overutilization of neighbouring turbines, loss of production, cable damage, and significant demand and reactive interventions to remedy these failures. And that's just to name a few, of course. Next slide, please. So to combat this, there are a few strategies and opportunities that the floating wind industry is actively considering, and inspection and maintenance and repair would be clearly needed within floating offshore wind. There's an opportunity for the industry to harness autonomous and robotic inspection and repair strategies, but this is hampered to some extent by a lack of demonstration opportunities and developed standards. Key maintenance activities range from tasks such as corrosion measurement, line retensioning and line replacement. So not all of these activities are suitable for robotics or autonomous craft, but their integration with sensor-based technology in the form of condition monitoring could be the perfect complement to move towards risk-based inspection strategies, avoiding the need to physically inspect, but instead support data acquisition and the deployment of sensors in time. Indeed, condition monitoring sensors come in a variety of different forms, such as strain gauges, load cells, and inclinometers. And these are normally focused on monitoring tension and positioning measurements. But new solutions could emerge, such as anchor position monitoring, which has the potential to alleviate preloading requirements during the installation, as well as a peace of mind that the anchors are located as they should be over several years of service. And the uptake of these solutions will ultimately be defined by the monitoring strategies employed by developers. And if successfully implemented, this could inform digital twin-based models, which have the potential to remove the demand on physical sensors over time, which have historically shown a low reliability rate and generally fall off within the first couple of years. Another aspect worth considering is redundancy and the need for emergency response plans. And it's essential that emergency response plans are developed at the design phase of a floating offshore wind project. While redundancy can alleviate the consequences of mooring line failures, it can also buy a bit of time for reactive maintenance measures. And there's also a school of thought starting to emerge that could this allow for more active repair strategies, allowing developers to decide when they will actually intervene to address a failure, allowing them to kind of select when the best time to intervene is in comparison to the vessel spot rate costs. Additionally, based on some of the work we have completed within the Floating Offshore Wind Centre of Excellence, developers have also expressed strong interest in sharing resources and strategies across spares and inventory, which has been employed to relative success in the oil and gas sector. So next slide, please. So on this penultimate slide, I'd like to revisit what this all means to vessel and specifically anchor handlers. Firstly, looking at the right, the analysis and insights team at the Offshore Renewable Energy Catapult estimate that we could have around 49 gigawatts of installed floating offshore wind capacity by 2050. And we're just at the start of that journey, as exemplified by the arrow on the chart. And this is going to see a significant increase in the number of moorings, mooring components to be installed and maintained offshore, and increase the demand for vessels. Indeed, when we consider that suitable vessels for most mooring and anchoring tasks have to be rated with a minimum bollard pull of about 250 tons, with crane capacities of between 200 to 400 tons to deploy some of the anchors, and the fact that bollard pull capacity is derated as the vessels age, an independent consultancy, Intellitus, have estimated that it could be as little as 9 suitable anchor handling vessels on the market by 2030. As we've seen, line lengths, chain sizes, and proof loading requirements are already stretching the capacity of the existing fleet. And furthermore, recent upturns in oil and gas and the demand for vessel time across all life cycle phases of floating offshore wind projects means that the availability of these vessels is put into question. A new build vessel will normally take between 2 to 3 years from vessel order to delivery. And as it currently stands, the average vessel day rates have not reached the levels to stimulate investment in new builds. But one thing is for sure, once we reach that point, the offshore energy sector will require highly capable and adaptable vessels to be built, and minimizing the dependency on specific vessel types and offering solutions that can lend themselves to as many tasks as possible. And indeed, we've seen an announcement just today from NOV who have mentioned about a vessel that is or have announced a vessel that is capable of installing both array cables and mooring lines. So my final slide, please, Phil. And to summarise briefly, I hope we're doing well for time. Standardisation and consolidation is needed across the supply chain, although that might be troublesome to achieve if we're trying to optimise on a per project basis. We need to, of course, harness that systems orientated perspective, considering the floating wind installation as one, but moorings are of course integral to all of that and provide that vital station keeping capability, maintaining the platform's location and also the integrity of the inter-array cable. Chain manufacturing could become a major sticking point, not only in the UK, but globally. And the supply of synthetic ropes should meet demand, although there is expectation there will need to be a requirement to upscale in production facilities. Anchors will be in high demand, and there is sufficient supply, although you do need to get your orders in early to make sure you have enough of those to install at your project. There's much opportunity for innovation, and novel systems are coming through as a profile, such as in the form of quick connectors and anchors, and development and demonstration and qualification will be needed to really provide confidence across the developer group. Mooring failures, mechanisms and modes will require close attention, and I think it's fair to say we should always expect the unexpected, and preventative and reactive practices may be developed to maintain integrity and minimise failure consequences over time. And as I've just flagged, vessel availability issues are foreseen, and there is a need for capable and adaptable, efficient new builds to be brought online in the not too distant future. Thank you very much, Phil.
Jack, that was fantastic. Absolutely brilliant. The questions are flowing in. She's really good, so keep those coming. But Becky, if you're happy to take the reins, we'll pass on to you.
Thank you both. Thank you, Jack. And also thank you, Phil, for letting me boycott a webinar with effectively a call for input for a piece of work that Regen are planning on undertaking. So quick introduction for myself, Becky Fowle, Energy Market Analyst at Regen, and I help lead our offshore sector. So as kind of alluded to, we're looking at doing a piece of work regarding innovation in the floating offshore wind supply chain. And this is kind of a call for input and evidence on this thought leadership piece. So next slide, please, Phil. Quick agenda. I'm going to run through who Regen are, the current floating offshore wind supply chain and the processes that it works, how actually integrating innovation will be in the supply chain, and how potential challenges that we think that the industry could be alluding to right now. And then also a quick wrap up of what Regen are looking at doing and how you can get involved. So next slide, please, Phil. Thank you. Oh my gosh, the formatting's gone awful. Never mind. So Regen is an independent mission-led centre of energy expertise. Our team consists of net zero energy system and low carbon technology experts who are dedicated to transforming the energy system for a zero carbon future. And all of our work is underpinned with detailed analysis and evidence-based research. In terms of the offshore renewables space, so we have over 15 years experience in the offshore renewables. This includes supporting the development of both the Atlantic Array and Navitas Bay wind farms. No comment that they're now not existent anymore. We've also helped develop and manage the Southwest Marine Energy Park, which created Wave Hub. And we've also recently done several pieces of work that have fed into kind of local and national policy pieces. So we've looked at the social, economic and technical supply chain opportunities that floating offshore wind offers for the Heart of the Southwest LEP. We've also looked at the whole system benefits and policy implications of diversifying the UK's offshore wind portfolio. And we've also looked into options for potential community benefits for offshore renewables. As kind of like a cherry on the cake, we also support the electricity distribution networks with their long-term strategy and network planning processes. This is known as the Distribution Future Energy Scenarios, or the DFES. So we've been doing them for the networks every year. Next slide, please, Phil. Oh, this formatting is very annoying, but never mind.
Sorry,
Anyway,
my fault.
no, it's both of our faults. Anyway, so to date, the floating offshore wind supply chain has leveraged key learnings from the fixed foundation offshore wind industry, which in itself evolved from the marine civils industry and also the oil and gas supply chain. So albeit that means that it's accelerated a lot quicker, it does mean that some of the solutions can be suboptimal or even an obstacle for the scale of floating offshore wind or the deployment that can be required. So the unique characteristics of the floating structures, along with some of the geographical and geological considerations of the deployment zones, for example, the Celtic Sea, demand alternative solutions to ensure reliable station keeping and physical stability of the floating offshore wind structures. I'm kind of preaching to the choir here, but anchoring and mooring solutions are a prime example of this need for innovation, particularly given the high operational and fatigue loads that are being forecasted for industrialized flow. Chain catenary mooring systems, for example, they require a significant amount of steel, and they also take up a significant space and require very powerful anchor handling vessels, as Jack alluded to in the previous presentation. At present, the limited availability of those vessels and also associated costs can present really large challenges for floating offshore wind. So that's just a kind of one key example of the need for innovation. Next slide, please, Phil. So extensive research has been conducted on the geographical and the technical requirements of floating offshore wind anchoring and mooring systems. Several innovative UK-based solutions are emerging, and there are also several SMEs, organisations within the Cornwall, South Wales and Devon region that are offering novel anchoring and mooring technologies, recognising the need for supply chain innovation to meet the scale of floating offshore wind needed. However, despite the high volume of floating offshore wind that is anticipated for the Celtic Sea alone, uncertainty remains on how these solutions will actually break into a kind of already well-established supply chain, which has inherited contractual legacy and existing relationships from other offshore industries. The inability for the innovative solutions and technologies to go into this established supply chain poses not only a risk to the commercial viability of the companies that offer these solutions, but also to the whole supply chain's capacity to deliver the vast number of anchorings and moorings needed. It's at the moment, minimising the short to mid-term project risk for developers is understandably a priority, hence why you go down solutions and organisations that you already have relations with. But are we really considering the risks associated with not evolving the supply chain to actually meet the requirements that will be demanded by the future flow? So what can be done if we go on to our next slide? So there are a few things that could be done. So as well as certifying innovative solutions to reduce the risk, the management of contracting entities and approaches to technical risks should be considered for project delivery and cost reduction. So Regen, partnered with Celtic Sea Power and Global Underwater Hub, are proposing a thought leadership piece. This piece aims to explore the contractual aspect of introducing innovative anchoring and mooring solutions into the supply chain, and it also wants to examine how associated operational and financial risks could be approached within the supply chain to better support innovation. So that's the kind of project as a whole. At this moment in time, we are looking for organisations that are willing to sponsor the research and join the kind of project steering group. And we're also looking for just any additional industry insights and experiences that organisations have had or challenges that you think could be upcoming. We are looking at doing this report Q1 next year. So please do get in contact. Next slide. Should be my final one, but yes, a really quick whistle stop tour. I appreciate I might run over a little bit, but yes, if you want to hear more and you're interested in getting in touch, do contact me and let us know. Thank you for your time.
Awesome. Thank you, Becky. Thank you, Jack. Yeah, that was brilliant. So thank you. I'll try to be as quick as I can, really. I don't Matt might want to chip in, but we've got questions coming in on the chat, so it'd be nice to catch some of those at the very least. So this is what we set down, and it hopefully dovetails beautifully with Becky's initiative as well. Is what we're looking for is we're really looking to try and draw out that proactivity. You know, in terms of the challenge as we understand it is there. The scale of it is slightly mind-boggling. I'd say some notes from Jack was testament to that. But we'll be, we aim to commission reports from private sector consortia, and these will be technically credible. We don't have to tell you your inner secrets. We really want to see what you're thinking in terms of ambition and how you can scale this up. We're looking at the list here. There's clearly companies who will be a major part of this solution. We don't want that to fall on the basis of the struggle to take the risk and the balance sheet on. So how can we do that? So in the process, we hope that you will form consortia to write these things. It's acting in our sort of slightly unique position as being able to act as a bit of a proxy client for that 4.5 gigawatts. You know, we're not going to be developing anything, but in terms of getting the scale of this across, how can we crack a few things that Becky mentioned about tier one inherited contractual supply chain? So it's trying to get across that, and all underpinning it is all how do we do that with positive impacts on Cornwall UK. That's not necessarily homegrown SMEs. That might be SMEs teaming up with bigger players from elsewhere, but it will increase GVA jobs in our region. Hope that's clear. There'll be more coming on that in the new year, so do keep in touch. And obviously you've got Becky and Regina well ahead of the game, so we'll really help this initiative. Just to land on that slide again, hopefully that's reasonably clear. I have to say, Anchors and Moorings is the first one for a reason. You know, we see huge potential for consortium to form to take on these big challenges. Looking with the investment and the backing of balance sheet and the interventions that need to make that happen. But I think with 10 minutes to go, got questions flying in. So if I just filter through those, I might throw them at Jack in the first instance. But if anyone wants to unmute and bring forward your technical knowledge, that would be very, very welcome. Mark, I'm tempted to bring in because there's obviously a bit of a conversation moving here, but you asked, could OREC curate a public source of representative design loads? Jack, is that, and Julie, I guess, is that already initiated? The things online already?
I think we must have given some sort of nod to the kind of appreciative loads that be expected in some of our reports. I appreciate I'm not fully versed with all of our previous reports before I joined, but absolutely, we will be disseminating publicly a few reports in time that will characterise the design loads and the maximum tensions that were encountered across a number of different projects that were extensively assessed by our partners at TTI Marine Renewables. And to give some sense of the loads, I think we saw loads ranging of maximum tensions, that is, of between 200 to 1,500 tonnes. Of course, you need to delve into a bit more detail and characterise that by the mooring spreads that were reviewed. But that just give you maybe a sense of the range to consider, Mark. But absolutely, there are a number of different reports that will be issued publicly in due course.
Great, thank you, Jack. Is that okay for you, Mark?
Can I just make a quick response? I mean, I think the thing is that's great, Jack. There's some great stuff out in the public domain. I've been looking at some reports from, say, Wise Baczynski and curated by the University of Southampton Group, but they're for the 6 to 8 megawatt turbines, and most of the projects we're talking sort of 15, 18, perhaps 23 megawatts, and so obviously the load's going to go up, and there's a lot of guesswork going on because the turbines haven't yet been designed. So the more that we can share, I think, as players further down the supply chain, the better prepared we'll be for that market when it emerges, and we won't be naive in what we're designing to.
Yeah, absolutely, can agree with that. And I think the loads that I mentioned were based on a 50 megawatt, the standard NREL 50 megawatt reference. But yeah, we will be issuing in the not too distant future other representations in terms of a reference turbine for those higher capacities. I can't really say much more, and I know others are looking at that too. So yeah, it might be an activity that we could embark on, is looking to characterise those loads in more detail across those representative cases. But of course, the biggest challenge that we have is having a representative structure that we can all work to and reference the loads up from as well. And so we will look to another entity and potentially ourselves at the Catapult to develop a representative substructure, whether it be a semi-submersible or a TLP, that will also be driven to some extent by the partners that operate with us in the Centre of Excellence. And there will be some limitations to what we can issue because the partners pay for a small fee to get access to that information, but there is a general keenness to make that information more readily available to the supply chain to help you all gear up accordingly.
Yeah, thanks, Jack. And the other question is not just turbines, but also platforms are probably not going to be anything like the high wind or wind float or float gen or any of these others, because those just going to be too heavy, too expensive, and too difficult to manufacture or mobilize. So I know you can't present results from very innovative designs that your partners have come up with, but the closer we have to something that's actually realistic, the less conservative we're going to be in terms of supplying buoyancy and clump weights and anchors and mooring lines and all the other things that are needed.
Yeah, absolutely. I mean, I think there's going to come up maybe a point in time where do the turbines and therefore the platform get too big? They're just unhandleable, for want of a better term. So maybe we do have to kind of address as to how big we let these things get. It's a whole supply chain and infrastructure issue as well, right? If we don't have the ports to launch them, we don't have the vessels to install them, then there's no point in getting any bigger. And maybe that's what we want to see in the offshore wind industry, but maybe that's not to music to the ears of the developers, of course.
Great, thank you. I think there's a lot of it really interesting. I think one of these things is that we sort of are worried that this passivity, we're waiting for the developers to articulate the problems which they may not necessarily understand them as well themselves. So can we put forward the solutions at scale ahead of that we have that address that first mover problem we have. But that's my bugbear. John, you've got a couple of questions. Always looking ahead. The consideration about decommissioning. Do you want to lob that one in, John?
Yeah,
John Best.
Thanks very much, Phil. It's just, we continue to say, let's not reinvent the wheel and promptly reinvent the wheel. So if we're putting these anchors in, how are we going to take them out? How are we potentially going to add their use into the circular economy? What consideration is being given to that at an early stage?
Yeah, it's a tough one. I don't think we've necessarily looked into a lot of detail into that part of the life cycle, as is often the case, unfortunately, across many marine energy sectors. But I think, with Dragon Bedment anchors, the idea is at least with those, you will be able to kind of just pull them the other way, and eventually they'll dislodge themselves. Suction anchors, again, similarly, if you can re-evacuate the water, and they should therefore lose their holding capacity and be recoverable. For those that are piled and grouted, I think the best solution that we have, taking the example of maybe fixed monopile examples from fixed wind, those are normally truncated and therefore cut at the base or the area in which they extrude from the seabed. So I think that's probably likely to prevail to some extent, but that does mean a lot of marine operations. So there will have to be an extensive assessment as to what that means in terms of the environment. Is there a case that actually you've almost created an artificial ecosystem as a result of those anchors? Is it sometimes better to leave those in place in time? Time will tell. Is there a case to also repower? Are anchors suitably sized to allow you to come back along with your new turbines, new substructures? I don't know exactly the answer to all of that, but it is a very important question. And we are working hard in the Catapult to understand what the overall life cycle cost is from an environmental and a carbon counting perspective as well.
Yeah, absolutely. Thanks, Jack. Great presentation. I came into this with some of the work that was looked at in the Gulf of Mexico and the rigs to reef argument, which was potentially created after the problem as a solution, as opposed to thinking ahead.
Yeah. Interesting to see how it all pans out.
Great. A question from Gary, which Julie might want to take. I'm not sure it's about, regarding the issue of Gary, online on ask yourself, that's not absolutely fine, but it's about the issue of deck space and a weight limitation for anchor chain transport to site. What investigation has interested in with regards to the use of an autonomous barge to carry surplus equipment offshore to support an installation vessel. Julie or Jack, looking to you for work on autonomy here. I was aware of the WASP project a couple of years ago to address this. I'm not sure if it came to anything, or if indeed autonomy is the right solution for this. But
I mean, it's like a holy grail, isn't it? If you could have autonomous craft going offshore and delivering the various components. I think there's a huge risk just sheerly by the weight and the size of some of these individual components. So you have to make sure that the autonomous vessels at that size are reliable before we can even consider delivering components in an autonomous fashion. But I think we have seen some solutions suggested in the market of a blueprint to what could be achieved in the form of maybe barges or kind of almost like hopper barges being transferred offshore with the mooring chains, and that alleviates maybe some of that issue about having to transit to and from port and reload chain on these anchor handlers, which are flagged as being a key logistical constraint. Having said that, when you're faced with a significant portion of chain offshore, the handling of that chain in the offshore environment actually becomes quite challenging, especially if you've got larger bar diameters. So that would have to come with a whole new unique set of marine operations to ensure that it's installed safely. So I absolutely accept the challenge, but I don't think there's an easy quick win there at the moment in the industry.
I can say, as formerly involved in MAS, I'm quite grumpy about it, is that it sounds like we need the vessels rather than to be autonomous in the first instance. And we've got people. So, but that's a MAS grump speaking. Question from Dan Starr. Hello, Dan. Asking directly if you, Jack, sorry, put you on the spot here. But it's to throw it out there, if other people disagree or have a different take on it, do bring it to the conversation. Great presentation. Are you aware of any challenging opportunities for scour protection for A&M systems? Is this likely challenge for the Celtic Sea? And I think also I had a pre-sub question about specifics of the Celtic Sea, which I understand is variable seabed. So, Jack, you cover that in 2 minutes. That'd be impressive. Or anybody else.
I mean, scour protection has been an issue in fixed wind for a long time, and there have been a number of different innovative processes and technologies to accommodate that. We've seen the use of rock bags used to good levels of success, and maybe some more innovative solutions from the likes of Balmoral, which allow for to kind of basically account for the laminar flow around the mooring foundation. The turbine foundation. So again, you would probably see variants of that nature be brought in for the anchors as needed. Although they may well be at a smaller scale, but I think they'll be largely dependent on the likes of suction anchors or piled anchors, especially those that protrude with their pad eyes in some cases above the surface. So there could be a need for that in time. I would have to do an extensive review in the Celtic Sea to understand exactly what the likelihood of seabed mobility in combination with tidal effects and different currents. So I couldn't possibly comment on the actual likelihood or the challenge of scour, and specifically in the Celtic Sea. But I think it's something that we're going to have to address. And again, all of those autonomous solutions that I mentioned earlier will be able to lend themselves perfectly to understand exactly what the mobility of the seabed and subsequent scour effects are in terms of mooring and anchoring solutions.
Thank you, Jack. You've really earned it today. I really appreciate it. I think we have to wrap it up. A minute to go, but as I say, this is the start of things. I know many of you have been thinking about it for some time, but hopefully we're going some way to articulate the challenge. And in Catapult and Regen, we've got real authority on there, but not necessarily prescriptive. It's the private sector that will ultimately deliver that, and we want that to be UK private sector. So those contractual challenges that Becky highlighted, and the cracking through the tier 1 nut is in the mix. So that's what we really want to think on and move forward very practically. So this is the start of things. We'll be pursuing this the next several months. So hopefully we'll be in touch soon. If anyone wants to stay on the line, which happened last time, we ended up chatting for about 20 minutes. I can handle that. I don't know if Jack can, but otherwise we shall see you at the next webinar, which I put the link in the chat, on the 4th, which is only Monday. So it's happening thick and fast. Other than that, thank you to Jack, thank you to Becky, thank you all.
Thanks all. Take care.
Thank you.